Here we want to look at some more, advanced, or not advanced, but slightly more complicated functions. And I regret there is a mistake here. There should be g of 2. Let's do f of 3. So f is given by this function here. G is given by this function here. So I'm going to evaluate it. So f of 3 is equal to negative 2 times 3 squared minus 3 times 3, which gives me, that'll be negative 18 minus 9, or negative 27. And for b, same thing. I'm going to plug in a value of 2. So I have g of 2 equals 2 squared plus 10, or that just gives me 14. Now, part C says, well, evaluate f of 3 and then subtract g of 2. Well, f of 3 is negative 27. We did that over here. Minus g of 2 is 14, negative 14. Positive 14. So when I subtract them, I'm going to end up with, what is that? Negative 37, negative 41. Okay, so pretty straightforward. Nothing too strenuous there. Just a different way of writing it. And lastly, it says, well, when do f of x and g of x equal each other? In other words, when do they intersect? Again, f, if we look at it, is a quadratic, which opens down. Okay, g is also quadratic, which opens up. And maybe they intersect, maybe they don't. We don't really know, but we're going to find out. How do we do that? Well, why don't we just kind of make them equal to each other? Okay, it asks when are they equal to each other? Well, let's plug in the values. So negative 2x squared minus 3x equals x squared plus 10. Okay, well, I'm going to bring everything over to one side of the equation here. I'm going to have a negative 3x squared minus 3x, then minus 10 equals 0. So I just brought everything over here, and it becomes negative. Can I factor this? Well, I'm looking for two numbers. Maybe I can do it without the quadratic formula. That had to give me negative 3, and they multiply to give me 30. Are there two numbers that multiply to give me 30? 6 and 5, 3 and 10, but none of those combinations will combine to give me negative 3 when I add or subtract them. So I think I'll have to use a quadratic formula here. So x equals positive 3, because it's negative here, plus or minus the square root of negative 3 squared minus 4 times negative 3 times negative 10. And that is all over 2 times negative 3. Okay, let's continue. What do we get? Positive 3. Well, I don't need that plus there. Plus or minus 9. Okay, so I'm gonna stop here pretty much, because I think maybe you can see why there's no point in going on. Negative 10 times negative 3 is negative 30. Negative 30 times 4 is going to give me negative 120, and my discriminant is going to be less than 0, which means no roots. That means no intersection. So without even finishing this question, because this is less than 0 under here, no roots. And that means no intersection. It's always nice to finish these ones earlier, instead of having to go all the way. Anyway, so that's function notation with slightly more advanced equations, but nothing too difficult. Soon we're going to be looking at new functions, which are things that you haven't seen before.